for gas? Gas is everywhere! See all this? This is gas! Gas is over here! Over here! Over here! Yeah! Gas! Gas! This is all gas! Gas!
Jen, Earl, the chemistry girl.
Jen!
Jen, Earl, the chemistry girl.
Chemistry rules.
Brought to you by gases for over 3 billion years. The scuba diving effect.
There's something called the atmosphere. It's a big layer of gas that surrounds the Earth like a blanket. Just like this. Yeah, all of it. See? This. What are gases? Well, gas is a state of matter that consists of a group of particles such as atoms, molecules, ions, without a definite shape or volume that are more or less random motion. Gas! The molecules in a gas have little attraction for each other because they are so far apart. In fact, most of the volume of air is just empty space. When condensed into a liquid or solid, the gas molecules occupy a very low volume, making them really hard to compress. That is why you can go like this with the gas. Whoa, is the air ever moving out there? Air sure is an amazing thing.
I sure can't live without it. Can you, Jen?
I sure can't. In fact, no one can. Well, did you know that the air that we breathe, cells require it?
But what is air?
Well, air is a combination of 21% oxygen, 78% nitrogen, 1% other gases.
Consider the following.
Gases have four main properties: volume, temperature, pressure, and the number of moles. The big four. Okay, so when we're scuba diving and we're at surface, we actually call that 1 atmosphere, and that's 1 atmosphere of pressure. Go down to 10 meters, we call that 2 atmospheres, and 20 meters, 3 atmospheres, and so on as you get deeper. And what's actually happening here is that at 10 meters, the volume of the air actually decreases by 1/2, and at 20 meters, and when we go down to 10 meters, we call it, and we're at surface, we actually call that 1 atmosphere, which is 1 atmosphere of pressure. And when we go down to 10 meters, we call that 2 atmospheres, and 20 meters, 3 atmospheres. And what's actually happening here is that at 10 meters, the volume of air is decreased by 1/2, and at 20 meters, the volume of air is decreased by 1/3. So here's an example of what would happen to the density of air when we go deeper. If we take the same size ball, it becomes more dense as we go further down in the water. So we can compare it to this. And then when we be at the surface, we can compare it to this. And this is because the same air would take up much more space.
Being underwater is like being in a different world. Humans were made to live on land. Because of that, it is very hard for us to go under the water. People breathe air. We can't live without it. So in order for us to go under the water, we must bring our air with us on our backs. Unfortunately, this doesn't solve all the problems divers face underwater. You see, the deeper you go, the more concentrated the air gets. Differences in pressure can have a very dangerous effect on divers, and here's why.
Oxygen under pressure can be toxic to the body because you're getting way too much of it. Oxygen toxicity can affect the central nervous system, causing disorientation, breathing problems, and vision changes. In severe cases, it can even cause a diver to have a seizure or convulsion. This seizure can result in the diver spitting out his regulator and drowning. The diver at first feel relaxed and in control of their immediate environment, when in fact being oblivious to the looming danger. The diver may then start to act confused and almost appear to be in a drunken state. In extreme cases, divers can even be stricken with exhausting paranoia. Nitrogen gas can also cause the bends. Decompression time is a resting period that may be needed when surfacing in order to allow your body time to safely readjust to the pressure changes. If in an emergency you had to surface quicker and did encounter problems such as the bends, you may be taken to a decompression chamber for help. You see, when you blow air into a balloon, the air molecules are forced onto the walls, which create the balloon to expand. And then, eventually can no longer take it, and it pops. Gases can be under pressure too. You see, there's this thing called atmospheric pressure. It occurs at high or low altitudes, like on this mountain.
Why do people go diving if it's so dangerous?
Well, people go diving because it's a way to discover a whole new world. As long as the diver follows their safety rules, they'll have a safe experience.